In this video, we're going to be talking about some exponent rules, and I'd like to start off with just some basic exponential notation for you. I'm going to write down just a nice, easy exponential expression here. We'll go with maybe 2, and then we'll raise that to maybe the 4th power. Okay? So the 2 is the base part of this exponential expression. These are called power expressions as well. And the 4 here is our exponent. Those are the two basic parts. You can see the base is normally bigger compared to the exponent, and then the exponent's going to be in the superscript position, which would be to the upper right hand side of the base. Now what this means is you're going to take the base, and the 4 is telling us how many times we're going to multiply the base. So this is 2 times 2 times 2 times 2. 2 times 2 times 2 times 2. There's 4 2's there. That's the exponent part. So the 4 is telling us take the base and multiply it by itself 4 times. Now with a number, you can actually go ahead and do this arithmetic. So 2 times 2 is 4, times 2 would be 8, and times 2 would make 16. So 2 to the 4th power, written down as just a number, would be 16. The same thing does apply to an exponential expression with a variable in it. And if we take a look at something like that, let's go maybe, to the 5th power here. And we can go ahead and we can do the same thing. We can write this whole thing out. We could write this as x, which is the base, and we got to write 5 of those x's. So that's an x, another one, that makes 3, 4, and 5. Only one problem with this one compared to the one with a number is that with a number we can actually go ahead and do that arithmetic over here. We can't do that with just the x's. However, this is a really good thing to do. So what I'm going to do is I'm going to put a little star or an asterisk, and what I will say to you is, this is kind of a big thing, is when in doubt, write it out. You can actually develop the rules that we're going to talk about if you remember this one little concept right here. So let's use that one concept to help us take a look at some of the rules. And the first one we're going to do is we're going to ask ourselves, what happens when we multiply like bases? So with this, you're going to have a setup maybe like this. Maybe you'll have y to the 3rd power times y to the 4th power. It's important to note that two things. You're multiplying, so the multiplication symbol has to be here, or you need to have parentheses, something indicating multiplication. You cannot do this if there's a plus sign, or a minus sign for that matter. Also, the bases have to be like. They have to be exactly the same. So a y and a y, those are exactly the same. Now, even if you forgot this rule, and we're going to use it to help us develop the rule, you can write it out. So let's write it out. This is y times y times y. That's the first one. That's y to the 3rd power. Y to the 4th power, that's y times y times y times y. And if you change all of this back into exponential notation, just like we did before, we said, hey, if there's 4 2's being multiplied together, that's 2 to the 4th power. Well, there's 1, 2, 3, 4, 5, 6, 7 y's being multiplied together, so we could rewrite that as the base raised to the 7th power. Now, you've got to start asking yourself, what is a shortcut for this? I mean, this would stink if you had to do this every single time. You can imagine if these exponents were really big, it would take you a long time to write out all of the bases. So the rule is, we've got a 3 and a 4 here. How are the 3 and the 4, what could you do with the 3 and the 4 to get it to be a 7? Because we know that it's y to the 7th power. It has to be. We used our exponent notation rule. That's the way it is. But the rule is, if you take 3 and add 4, you get 7. So that's where this comes from. And the rule then would be, if you multiply like bases, you add the exponents. That's just the way it works out. It's an often made student mistake and a bad assumption to think that we're multiplying these bases together and that you multiply the exponents. You definitely do not. 7 is not 3 times 4. 3 times 4 is 12. That's not a 12. So it's 3 plus 4, and that's got to be 7. Let's take a look at another thing that's very similar to that. Let's see what happens if we divide like bases. And we'll check this out here. So let's go maybe c to the 5th power, and we're going to divide by another c, and let's make that c squared. So c to the 5th power over c squared, we're dividing like bases. The c and the c are the same. Okay. We can use our when in doubt, write it out to help us develop this rule. So there's 5 c's. And then in the denominator, we've got 2 c's, that's c squared. And now we can go ahead and we can cross off c over c and c over c. c over c is just 1, and 1 times all of this is just that same thing. So we can just cross them off, those are equal to 1. And what we're left with up here in the numerator is c, and there's 3 of them, so we can change that back in exponent notation, that is c to the 3rd power. Wonderful. Well, how do we get from 5 and 2 to 3? We definitely don't divide 5 by 2. Definitely not. That's 2.5, it's not 3. It's close, but it's got to be exact. Over here, you can see when we multiplied, we actually added. So multiplication and addition kind of go together. Here, then, division and, you guessed it, subtraction would go together. So 5 minus 2 is 3. So when we're dividing like bases, you're going to take the numerator's exponent and you will subtract the denominator's exponent. That is the rule. If we take a look at another one, I think I'm going to have to use another sheet of paper here. So if we take a look at one more rule, and this is going to be the wonderful power of a power rule. So I'll go ahead and write that here. Power of a power rule, very powerful rule. You're going to have a setup like this. Maybe you're going to have x to the 3rd power, and then let's raise that to the 2nd power. Now this exponent of 3, belongs with the x, and the x only. This 2 belongs with everything inside the parentheses. So what this 2 is telling us is it's telling us take everything in the parentheses and multiply it by itself. So that's x to the 3rd times x to the 3rd. You can see we've written the base, which in this case is x to the 3rd, twice. We don't even have to write this out anymore, because before we developed a rule, and this handy dandy rule right here, when we're multiplying like bases, we add the exponents, will help us with this one. So this one is actually going to be x to the 3 plus 3, or 6th power. Same thing again though. This is nice, we've used a previous rule, but let's develop a shortcut. We want to go right from this one, right over here to that one. You'll notice that the base is the same, so you keep the base. And what do you do with the exponents? So in the past, when we multiplied the bases, we added the exponents. When we divided like bases, we took the numerator, subtracted the denominator. And this one is going to be a little different. 3 times 2 would be 6. So we had addition and subtraction before, and now we've got multiplication. So when we take a power of a power, or raise an exponential expression to another exponent, all saying the same thing, what you do is you multiply these two together. Another example, let's say that you had, we'll go with a to the 6th power, and you raise that to the 100th power. Well, you wouldn't want to write out all these A6s, it would take you a long time, but you know now, using some smaller numbers and using a little bit of what you've learned in the past, you can just go ahead and multiply these together. So that's A to the 6 times 100 power, which is A to the 600 power. And isn't that wonderful? You didn't have to write the whole thing out. You can use your knowledge of mathematics and extending a pattern to easily simplify this expression on the left.